Strong means make sure that even if other parts of my program don't need this pointer anymore, whoever's implementing the class, the property in question, do care about it. So make sure that I plant that stake in the ground and +1 it. Weak means, yeah, it'd be nice to have this pointer around, but it's not a huge deal if someone else frees it because it's not owned by me. And so indeed, the rule of thumb is this. If you are going to be using the property to point at some object that you have allocated in code, it should almost always be a strong property, because clearly if you allocated the object, you probably want to keep it around. If by contrast, you are implementing a property that points to an object that someone else allocated in some other class or in interface builder in a nib file, then it's probably fine to make it weak. So in other words, things like IB outlets that allow you to link your code to a nib file, even though the nib is yours, the nib is what's responsible for allocating the text view and the button and all of the UI stuff. So those objects are not owned by you per se, so a weak property suffices. So that rule of thumb should pretty much get you through almost all scenarios now. Carl. Almost always. You should never use release anymore. In fact, Xcode will yell at you in red if you call release or try to call release, and something called ARC, automatic reference counting, is actually enabled for that project. You can get away with calling retain, though it should not be necessary. And indeed, you should just get out of this habit now or pretend you never even heard of these things. And we mention them today because, again, we've seen them on the help boards and whatnot because people are understandably copying and pasting sample code from online and tutorials and just realize it's dated. So auto-release you can actually use. So we've actually seen auto-release in one place consistently. Where is that? Yeah. Sorry? Actually in main. So not in the app delegate, but in main. So if I go ahead and let me open up SQLite again, just as representative of this. Recall that in main, there's this auto-release pool that kind of wraps everything the application does. So auto-release pools have been traditionally helpful for methods whereby you yourself did not call alloc, but instead you called a convenience method. So per Zach's question earlier, you can allocate a string with literally saying NSString alloc in it. And as of a year ago, you, the programmer, would have eventually had to pass in the release message because you need to undo the effects of alloc. Alloc gives you +1, release gives you -1. So as of a year ago, you would have to have that release call in there. So auto-release, though, is a feature of Objective-C that allows you to have convenience methods like NSString, string with format. Clearly, that method is allocating memory. Otherwise, where would you put the string that you're creating dynamically on the fly with various printf-style placeholders? But if you're not explicitly calling alloc, the rule of thumb was you better not call release yourself. So rather, there's this notion of an auto-release pool whereby you can tell the operating system, you know what, this eventually needs to be reclaimed, but I'm not sure when, so allocate this memory not just from the generic heap, but from something called the auto-release pool. And I promise in return for this wonderful flexibility of not having to call retain or release myself, that as soon as that auto-release pool is drained, so to speak, then you can take this object away. Now, pool is just a collection of memory. Draining it means freeing all of it at once. So what's the implication of having this in main? That your pool is filled with a free memory, so filled with water, filled with memory at the very start of your program, but it's apparently not drained until when? Infer from the curly braces. Exactly, until UI application main is done, at which point, game over. The program is clearly done executing because main is the thing that starts and ends the program. So this almost seems useless. So for the more sort of sophisticated programmers, if you actually have like a for loop in your code or a while loop that has to allocate memory again and again and again, so a tight loop, so to speak, where you're just accumulating a ridiculous amount of memory on the heap that you actually don't want to unintentionally leave around in RAM until the very end of your program, you yourself can actually write @auto-release pool with some curly braces inside of your own for loop so that as soon as your tight for loop is done doing whatever memory management it wants, then that memory is immediately freed. So it allows you, the programmer, more fine-grained control over when memory is freed and how much clutter is building up in RAM. So the upside here, if any of this is a little abstract, is that for the most part, you don't have to worry about this anymore. But understanding reference counting and this +1, -1, and this idea of keeping objects around by explicitly planting these stakes in the ground, these days with the keyword strong, is a nicer version than what you probably keep seeing in books and online references. So in short, don't do what's crossed out. Do assign strong and weak for all of your code, as by checking the arc box when you start a project. All right, any questions? All right, so this is one of these lessons that literally, not until like past recent time, have I actually gotten into the habit of writing tests for my code. And this was mostly because no one ever made me do this. But thankfully, there's now a course called CS164 that will make you do this. What are unit tests, so far as you know, if you do? Yeah?
There are little methods that you write that test values or functionality of the code.
Okay.
That you run automatically before building.
Okay.
So that if there are any errors, like you don't have to manually like input values to things to make sure it works.
Perfect.
You should count like the nulls or like make sure that the values are what you expect.
Okay, perfect. So they are small methods or functions that you yourself write that simply test other functions or methods that you yourself have written. Right? If you think to yourself, think back to even something like CS50 or whatever first CS course you took, and you finished that problem set and you got the number of Skittles or pennies right, or Mario, or whatever your first problem set actually was, and you felt so damn gratified at like 2 a.m. The thing works. But how did you know it works? How did you know it was correct? What gave you the confidence to actually submit that thinking you were done with the P set? Like in real terms, like how did you know it was time to submit besides the fact that the deadline was 2 minutes later? How did you know your code was done?
You could see Mario moving.
Okay, so you could see Mario moving. In the case of Scratch, you could actually see some visual results. And how about in C, when we finally moved away from the GUI? How did you know that some C-based application, or Java, whatever your first language was right? Yeah?
It matched the sample output of the spec.
Okay, good. So it matched the sample output. So this is actually a reasonable testing mechanism, especially if your whole program is written in main, and main simply has functions like printf that print out to the screen. You can certainly correctness test just by comparing output. But once you move into the world of object-oriented programming, and indeed away from main, which pretty much does nothing now except defer all execution to UI application main, something else altogether, you start to have many, many more method invocations inside of these objects. So how do you now begin to test whether this method is right and this method is right? You can look at the aggregate output, but you know from most any program you've written, there's always corner cases, right? And if you had a really sharp TF, he or she almost always found the damn corner case that you didn't think of, inputting -1 or 0 or a billion or whatever the corner case was, right? Unless you manually test all of those cases yourself, it's hard to be confident that your code is correct. So unit tests are all about writing methods in addition to the ones you care about for functionality's sake, but methods to test those same things, right? Indeed, if you look at the comments in your methods, or if you look at someone's comments in their commented methods, generally the description of the methods will say what the parameters are, what the function or method does, and then what the output is supposed to be. So we might have a method, and let me just pull up something random, like pull up a text editor here. And we can have, let's say, an instance method that returns an int called add x and y. And this returns sum of x and y. All right, so this is a method I wrote in some class. What would it mean to actually test this method? So then let me go ahead and, in pseudocode here, write a test method. So this is going to be something that returns void that's called test add, and it doesn't take any arguments. But in here, I need to test add. Okay, stupid looking method name, I realize, but test add and. All right, so how do I go about testing this method? And assume now that these things are in separate classes. So what would you do to test this method? What does it mean to test the addition method? Yeah, Zach.
Call add on like a negative and positive number, 0 and positive, like different types of numbers, and try to make and check against what you expect the value to be.
Okay, perfect. So we essentially want to test whether, let's say, add and returns 3 for 1 plus 2, right? Test with specific values and then check the return value. So how might we express something like this? Well, we could do something like assert is equals, and this is again pseudocode, that x add well, let's say object. So whatever my object is, let's pass in add 1 and 2, comma, let's say 3. So this statement here is actually common to a lot of languages. This notion of asserting, whereby the goal of an assert statement in general is kill the program here if this line of code does not evaluate to true. So the pseudocode function here is called assert is equals. I'm passing in 2 arguments. First, I'm passing in the return value of the add and message being sent to some object, and I'm hopefully going to get back what value, obviously. I'm hopefully going to get back 3. So the second argument is the value I actually get back. So in what sense is this a unit test? Well, one, it's a method that's testing another one of my methods, but it's doing it on a very small scale so that I can very easily see, is this method behaving correctly? Now, I'm not going to go ahead and start enumerating thousands and thousands of examples. So these are not proofs of correctness, as you might discuss in CS121 or CS124, because rather than we would have to try checking, either proof this thing by induction somehow, or we'd have to test all possible inputs to this function, which probably isn't the best use of time. So with unit tests, testing things like the corner cases, like 1 and 2 is kind of reasonable. But you know what could be an interesting one? How about -1 and 1 had better equal 0? And then another one could be something, again, unexpected, like what if I do 0 and 0? That better be 0. So all those corner cases that verbally for years you've been encouraged, like think about this, you can literally check those things by writing these tests. And what happens is then with your compiler or whatever IDE you're using, there's usually a command you can run or a button you can click that will run all of your tests automatically for you, allocating your objects as needed, and then it will tell you which of your various assertions failed. And the upside here is that as soon as all of your assertions pass and you get no red warning output on the screen, you know my code is correct, at least so far as my tests are concerned. So if you've ever wondered what your TF might be doing behind the scenes, he or she is probably running the equivalent of unit tests, because he or she hopefully is not manually testing and writing programs manually to test all the submissions of 15 plus students. Rather, we write things that are much more automated than that. So with unit tests, you yourself can do this so that, frankly, the next time you change your code at like 1 a.m. and you hit save and then you submit it thinking, oh, that's all fine, right? You actually have a sanity check that you yourself wrote that can say yay or nay, you just broke all of your code. And better yet, now that you're working with a partner, right, you have this contract right now based on trust that he or she is not going to go and screw over your entire project by introducing some bug. This way, you can actually validate that his or her code is correct, or at least correct so far as the tests are concerned. So there's this other buzzword in this world of testing called regression test or regression testing. What is a regression in the context of software development? Yeah.
Something that worked before but no longer works.
Perfect. Something that worked before but no longer works. Like you have regressed in the literal sense to some earlier, poorer form of the code. So a regression test is typically a test like this one, test add, that you yourself would write when you realize, damn, we just introduced a bug. Let me make sure I never again make that same mistake. So you introduce a test to test the input and output of some method so that if you do ever break it again, you can detect it and you can fix it before you actually push your code out to some production server or some actual device. So unit testing, and I honestly am quite happy to admit, I didn't do this for years because it always seemed like bureaucratic headache and nonsense and all of this. But the reality is even I am now in the habit of writing tests for my code as I write my actual code in parallel. There's a mental model that some people have where test-driven development, where you actually write the tests first for all of the methods you promise to implement, for instance, in your design documents, and then you write the code, because then you have instantaneous answers as to whether or not your code is correct. And again, an astute person will realize there's this infinite recursion potential where what if your tests aren't correct? So generally you don't write tests for the tests, but you write the tests in a sufficiently succinct way that there really is little, if any, room for error in your own tests. And you typically use a framework, like we'll introduce after the break, that you should hopefully be able to assume, since it was written by Apple, it's used by millions of people, so at least it's gotten lots of eyes on it, itself is correct. And probably the weak link is going to be your code, not the rest of the world. So why don't we go ahead and take a 5-minute break here, and then we'll start actually writing some of these on the fly. So before we dive into some actual test writing, a quick review question that I waved my hand at and then forgot to come back to before. So this was the SQLite example. This was the viewcontroller.m file. Why did I have my property here declared in the m file as opposed to the header file, which is where we started putting properties a couple weeks back? Yeah?
You don't want anyone else to know about it.
Yeah, so if you want some notion of privacy whereby you, the viewController class, are really the only one who cares about this property, and you've declared it so that you get the